I already am really curious about something after the United talk. The absolutely fire line was the repo grows, but the context window is limited. Like that tends to be like you can vibe out something really special and pretty impressive right away. But then when you get into enterprise software, lots of connecting systems, hundreds of tools, you start to like come right up against that context limit. So first thing I want to know actually is how does LangChain build LangChain and Langsmith?
It's a good question. I don't think we're probably not the model kind of like AI adopting company, honestly. Like they're practically speaking, like what we do is we give people a choice of their coding agent. We're pretty liberal with that. We have most people using either Claude Code, Codex, or Cursor, or we have Open SWE, which is our internal kind of like background style Devon agent. And so it's some combination of that. We have a few kind of like, we have agent.md files, a few skills. The best skill we have actually is maintained by our security lead. I think it's called like Langster skill. It's supposed to prevent bad things from happening in our repo. We experimented with a few AI code review tools. We actually ultimately ended up building our own, so OpenSWE review that will probably open source at some point as well. This is just recently that we ended up churning off of some other ones or building our own there. Yeah, I'd say maybe like the best thing we do is we have this like OpenSWE that sits in a Slack channel and then people just message it and ask it to build things. And so this leads to, I think we tweeted out a doc of documentation PRs, like basically doubling as soon as we implemented that, because people before didn't want to like pull down the repo, make a change, push it up. But it's so easy to say in Slack, like, hey, this needs to be better documented, or this should change. This shouldn't say X, it should say Y. And so that's probably the most unique thing we have.
Nice. Well, I figure it's always interesting to hear how, cutting edge Valley Tech companies are building, especially since you have your own coding agent now that you've open sourced as well. Where I wanted to take tonight, because we're in Chicago, is how agents are affecting enterprise. So not just building software, but I think like really agents, we all use agents as builders to write software, but then real businesses are now using agents not just as like customer support tools or things like that. They're like living inside of systems, changing things, updating records. And so I'm curious, like, is there an agent that like is your favorite that is built on LangChain?
Oh, that's a good question. I mean, my favorite agents are probably the most creative ones. So it's probably not inside an enterprise, but I remember meeting someone at Interrupt, which is our annual conference, about a month ago. And they were building an agent that sat inside of a video game and act as like an NPC that you could interact with. And I thought that was super cool. Oh, that's really cool. So those are my favorite agents.
You said it was a agentic operating model white paper. So I loved that paper. If you guys haven't seen it, I highly recommend go download it, read it. Don't just put it into Claude and let it summarize it. Like actually read the paper. But it's worth the read. Like all these enterprises have gone through so many transformations. We did, an agile transformation. We did a cloud transformation, and now we're doing an AI and agentic transformation. There's all the software side of the AI transformation, but what's the organizational change that you see companies needing to like adopt?
Yeah, I think it actually stems closely to the software side as well, or at least they stem from the same thing. Like the reason we need new pieces of software is that fundamentally agents are a new type of software. They're non-deterministic and they're driven by LLMs. And so the same thing affects kind of like the people and process side of things as well. So people need to understand what non-determinism means and understand how, hey, you might run the agent twice and it might produce different results, and why is that and what should you look for? Agents and that maybe gets into building agents. In terms of just like debugging agents, like how do you debug agents? What is the context? What does the context window even mean? How does that affect things? How can you change things to affect that? In terms of using agents, hallucinations exist, and you need to not have it be completely autonomous. You want to have humans in the loop at some very kind of like key points, and that's a lot of UX design in terms of thinking about these agents as well. And so we see that there's throughout this life cycle, there's new things that generally get inserted. I'd say most of them have to do with kind of like the quality of the agent. And so I think building evals and thinking about evals up front is a big part of that. And then likewise, just like there's like SREs for applications in production, there is this new style of like AI reliability engineer that's looking at these agents in production, and is it actually doing what users want, or users are using it in new and kind of like interesting ways. And so, I think it's fun and easy to get swept up in kind of like all these agent changes, but it's important to remember like what's actually changing at the end of the day. And I think the biggest thing is now these LLMs are part of the applications you're building, and that means new tech, but that also means new skills and new processes.
So I started software development at a little company called ThoughtWorks, doing test-driven development, and actually the root of test-driven development being pulled through into agentic, where you start with those evals and you just like define what this agent should be doing with a handful of examples. Just seems like such a nice way to begin, at least.
There's a good, I don't know who's, multiple people have said this, but like evals are like the new PRD. Like it's basically defining the spec of what the agent should do. How do you want to what scenarios do you even want it to handle? How do you want it to handle those scenarios? And I think there's a lot of, I think it's hard to even enumerate that. And then it's hard to create evals that properly kind of like capture that as well. It's a real skill, but I think just like, I think it will become a crucial part of building agents.
Yeah, and they evolve with the agent over time as well. So you might start with just a small handful because your agent only does one thing, and then you add a few and you add a few.
And it's really annoying because agents evolve fast as well. So we have an agent that we just launched in our project, in our product called LangSmith Engine. So basically LangSmith is our observability platform. You trace all your agents there. We have an agent that sits in LangSmith, it runs in the background, runs like on a schedule every 6 hours, looks at all these traces, tries to identify issues and propose fixes. It can propose code changes or adding evals or adding data sets. So we're writing evals for this, and we want to create issue bench. This is a benchmark of issues and how well this agent can identify it. It's actually quite hard to create this. We've been working on this like 2 or 3 weeks already internally, and now by the time like we still haven't finished, and the agent's already changed. Like it's already doing way more things than we thought it would initially. And so it's hopefully, like I think as it becomes, this is still a very new agent for us, and so hopefully as it becomes more mature, there's less kind of like volatility in some of these evals, which we do see. But yeah, it's you got to keep on evolving them, and agents evolve fast, and evals need to evolve fast.
100%. I do love that you say, this is really hard. It's taken 2 to 3 weeks and we haven't finished. Like, not a world of software that existed 6 months ago. That's wonderful though. Yeah, it's such a fast moving world, and we get to do it. One of the things is like, that's actually incredible, because when you're building an agent at a bank, and a bank has a 6-month change review process or a quarterly release process, and you're in this like rapid speed of, this is hard and we're not done in 3 weeks. Like, how do you reconcile those two things? And how is a bank or an airline or an insurance company going to stay on top of agents?
It's a good question. I mean, I think there's like a few, kind of like factors at play here. So one, like we're still very much in the very, very early innings of our agent. Like one of the things that we recommend is that you ship early and then iterate quickly. And so we're trying to dog food our own advice. And I think we built the beta version of this we built the like very beta version of this in a month. We dog food it with customers for like 2 to 3 weeks. We launched it at Interrupt, which is about a month ago. So it's been out since then. So it's still pretty early on, and we're constantly kind of like evolving it. And I do think we have a luxury that you may not have inside of enterprises. Like I think there's less red tape for us to there's less organizational kind of like red tape for us to run through. And so shipping quickly and iterating quickly after that is easier said than done, but I think we're trying to do that as much as possible.
And I think that was like a big part of the agile transformation, like moving away from waterfall development, and where, you have these huge release gates and you get a little bit more iterative and a little bit more iterative. And then we've gotten into the cloud, so our infrastructure is more dynamic now. So this is just this next phase, what it feels like, of pushing our companies to release faster. And there's definitely risk that you have to put around it. I like the United guys in their talk. They say, like, sometimes you're dealing with payments data or PII. And so maybe we slow that part down, but this one other agent over here can move super fast.
I think there's also UX design things you can do. So the first version of our agent, which we didn't ship, actually opened PRs directly in a repo. And I actually had a really hard time understanding the UX of that agent. And at that point, we had 2 people on the team, Ben and Palash, who are pushing this agent forward, and they've done a terrific job with it. And when it was opening PRs, to be honest, like I didn't get the agent at that point. I was like, I don't want an agent opening up PRs, it's going to spam. Like we have so many AI generated PRs on LangChain repos. I was like, I do not want more of those. And then we changed the UX to be more similar to if people have used Codex Security, basically their product where you point it at your code base, it runs in the background, it then shows you issues, you go in and there's a button and you can see the changes that it would make, and then you click that button and it opens a PR. And so we changed it to that. And I think that's a really good example of, again, practicing what we preach, which is basically like find these places where you put a human in the, where you can do a bunch of work, but put a human in the loop at the end so that they're still reviewing it, they're still in control. And so I think that was a small UX change that we made that, you know, changed it from being something that I was struggling kind of like to justify shipping quickly to now it's like, okay, we ship it fast. The worst thing that happens is you don't look at this tab in LangSmith, like nothing bad happens. And so I think we limited the blast radius a little bit.
I like that. And I really like the engine product. Like it suggested some things for our little Reachy robot outside, and we've been using it on other stuff as well. I like the UX thing is actually really interesting. We have the luxury of building agents for dozens and dozens of customers and enterprises. So we see a lot of different patterns. And I think everybody naturally gravitates to a chatbot, like because that's what they use for AI. But the most impactful applications are actually when we've deleted the chat window and the AI just kind of runs in the background, and it almost understands what the user should have been asking. They don't need to understand a magic incantation of words to call the right tools and all these other things. Are you guys seeing that kind of stuff too? How do deep agents fit into that? I know you used to talk about ambient agents a lot.
100% we're seeing this. Like we've added a few agents in our product. I think Engine is the third one. So first, technically we launched Insights, which was kind of like a similar thing, but it didn't take actions. It just showed you kind of like information. And then after that, we launched Polly, I think now renamed to like LangSmith Chat or something like that, which is just a chatbot. And then we launched Engine. And I think Engine, in terms of UX, we've heard much better feedback, and we think it's much more impactful for the reasons you described. It runs in the background, so you don't have to kick it off. So like knowing when to kick it off is actually a cognitive burden that we want to overcome. And then Insights was great. It would show people interesting things, but like, what do you do next? That was like, how can we close the loop more? How can we go further? Because it's great to have these insights, but you want to action on those insights at the end of the day. And so, yeah, I think we wrote a blog post over a year ago at this point called kind of like Ambient Agents, which is basically agents running either like on a cron job or triggered by events, basically in the background. I totally think that's the future of where things are going. If you think about an enterprise in particular, there's a ton of processes that are happening driven by humans, and a lot of these, if you think about an AI-powered enterprise, you don't want them fully autonomous, and so human in the loop becomes really important here. How do you surface to the user what the agent is doing, and at what points does it need to step in and approve things? But you do want these processes running in the background that just do things. Like I think about agents sometimes the same way as like a smart intern that you have as your company. You want the intern to learn to do things over a longer and longer period of time. If you're constantly just like slacking with them, it's exhausting. Like it doesn't give you leverage. And so I think background and ambient agents gives you way more leverage.
100%. We've done a handful of agents where actually like early in the engagement, we delete the chatbot. So like working with an insurance company, they had a chatbot especially for their like claims agents, human agents. And instead of having no one used the thing. And so instead of having the claims AI agent be its own little chat, we pulled it into the ticketing system that they already used, integrated with that. The AI agent would, look through the tickets, look for ones that it knew it could handle, pick them up, add information to them. We did the same for Let Us Entertain You here in Chicago with a handful of agents there. Went for a bank, delete the chatbot, get in there and solve the issues. Kind of the agent can know what the people want based on the context. You have that focused framework. There's context around that can trigger an event and then just like shows up for the person versus being asked.
I think one of the trickiest things with ambient agents is the like UX for how you expose either what it does or the work it did or when it gets stuck. I'm curious for those things. Like, did you end up building your own UX to see the agents, or did you integrate that with like an existing platform?
So on the technical side, we use LangSmith for all of that. And actually LangSmith has been a really powerful like governance tool as well. So there's a big question is always, when an ambient agent exists, where does accountability lie? So if someone prompts a chatbot and it does something, it's really easy to say, oh, we'll forward those credentials through and it's that person's responsibility. But if there's just something doing stuff, especially if there's write action to take, but even read action could break past a permissions boundary or something like that. We use LangSmith for a lot of that. And so LangSmith, with evals, with online evals, taking sample data, you can start to have alerts to understand if these things are doing what they should be doing. And then for the user specifically, we meet them where they are. So for the bank, it's wanting to meet the finance managers in their inbox rather than in a chat window. For the claims agents, we want to meet them in the claims management tool that they already had. And I think that's actually why OpenClaw and Hermes Agent were so popular, is the interface was right in what we all use. It's in WhatsApp, it's in Telegram, it's in Discord. Deep agents existed everywhere before then, but they were right there in the tools we already use, so it just felt more integrated into our lives.
I had actually not thought of LangSmith being more powerful for ambient agents because of that, but that's good. I'm going to steal that.
Good. Please do. Please do. I'm going to steal the focus framework from them because it applies really well to my company. Who writes the evals? I think is one of the really hard questions.
Yeah, it is. And I think it's getting harder as evals increase in complexity. So I think if you think about kind of writing evals for a single shot LLM call, I think what we saw is that there was a big push to have product managers, domain experts, subject matter experts involved in that. Whether it's by writing, there's different types of evals as well. So one type that we saw was people would write out the ground truth. Another type is what we call kind of criteria eval, where it's harder to define the ground truth, but you can write out some criteria like this should mention X or this should not mention Y or something like that. And so we have the annotation queues in LangSmith where we saw a bunch of people sending runs, and then domain experts would come in and label those, and those would get brought into data sets. I think it's becoming trickier for a lot of these longer running stateful agents. So one of the things that I've actually been playing around with in my spare time is there's an open source framework for running evals called Harbor, which if people are familiar with Terminal Bench 2, which is a really good coding benchmark, this is the framework that uses. And so we've done a bunch of integrations with Harbor, and so that you can run deep agents in it. Everything gets logged to LangSmith. You can use LangSmith sandboxes to run a bunch in parallel. But the tricky thing is you basically have to create a little simulated world for these agents to run in. And you have to do that because these agents are now really complex. Sometimes they're interacting with stateful systems. And so you need to mock those out. You can't so we use this for our issue bench thing for LangSmith engine. We don't want to hit production LangSmith servers, so we mock out a fake LangSmith server. We have to purposefully create simulations where we know that it is bad or where we know that it is good ahead of time, because that's the best way to get verifiable kind of evals. And that's why it's taking us so long to do it. It's a hard task. And I think I think there's I don't know what this will look like in the future, because I do think it's domain experts that are the people that are best qualified to say kind of what is right, what is wrong. But if you have to create this mock simulated world, that's a pretty tough engineering challenge as well. And so I think it's actually, I guess I think it's slightly easier. I think evals are I don't want to say easy, but easier for kind of single shot things. But for agents, they're really, really hard.
Especially when you start getting multi-turn tool calls, that kind of stuff, failures, that 100%. I mean, we find ourselves in the ratio of the enterprise, a software team would often consult a subject matter expert. So if you're building a bag handling app at United, which I had the privilege of doing in a past life, we had baggage handlers and people who ran ran the belts and all that kind of stuff consult with us on what the app should feel, look, and act like. Now I actually see them becoming more and more integrated in the team. We can prototype so much faster. So instead of using archaeology to extract information out of them, we can actually build a prototype, be does this make sense? And then that turns into an eval, and then that lives there. One of the things that happens though is these evals are compounding in cost. And eventually they become a little bit eye-popping to a CFO. So we used to run, you could run a JUnit test suite and it cost $0 effectively. So how do you balance the cost of evals to the testing of deterministic software around them and that kind of stuff?
There's different types of evals and you run them at different stages. So we have some more like sanity check evals that we run for Engine that are smaller things like, does it make the first tool call correctly? Like they basically single pass kind of like unit tests for in specific situations. And then we have issue bench, which is our long end-to-end thing. Yeah, I don't like seeing how much it costs to run on that. And I think like you just run them at different periods. So like we see people doing, there's also like, these are all automated evals, but there's also a big kind of like manual QA process for a lot of these apps as well. And so a lot of companies like, it depends a bit on your release process, but if you're rolling a big change out, you might do the heavy benchmark plus manual QA and have people go through. If you're doing smaller changes, you might run these small kind of like smoke unit tests. There's basically a gradient that you kind of build up.
So you just rebuild the testing pyramid.
Yeah.
With evals. It all comes full circle. I mean, like the resource we had before was time, right? And so we would run the integration tests infrequently and we'd run the unit tests frequently because integration are expensive in time. Now they're expensive in time and money, which makes CFOs care a lot more. I'm thinking about like conversations I'm having when we're out talking to customers or potential customers. And one of the things that comes up all the time is in the cost space, so the FinOps space as well, like how do you decide what model to use and how do you make sure, this open source model is as good as this, Opus model or something like that. So do you guys benchmark all your models? What's your process there?
Yeah, I think, and by the way, actually, this ties back to something you asked earlier, which I forgot to talk about, which is like basically the change management of a lot of these systems. Like, yes, you want to iterate quicker on the underlying system, but another thing that we have happening that didn't exist in software is new models come out, or models might get deprecated, and that's outside of your control. You have to be able to update the agents, not just because you're learning about what makes the agent better, but because there's a new model or the old models get deprecated. And so you need to basically have these evals in place to ensure those get rolled out smoothly. In terms of what we see in terms of models, I mean, I think over the past few months, we've started to see a much bigger focus on cost. I think adoption is finally getting there, basically. I think Uber's CFO came out and said they blew through all of their tokens for their coding agents in the first 4 months of the year. They're an AI forward organization. And so probably not all organizations are like this, but we're like this internally. We absolutely are starting to look at our coding agent costs and evaluating open source models, evaluating what the heck we do when Anthropic gets rid of their $200 max plan because it's subsidizing so much use. And I'm very bullish on open source models. I think GLM 5.2 came out last week. And from all, I actually was using it. I was using it literally today. And I think, and the reason I'm talking about coding agents is because honestly, I think like that's where a lot of the usage is. I would bet enterprises are spending more on coding agents than they are on first-party agents that they provide for the most part. There's obviously some exceptions, but I do think the same thing will happen with first-party agents as well. We see it happening with Engine. At the end of the day, Engine's a coding agent that runs, and so we use different models for sub-agents. So we use cheaper models for sub-agents that we spin up more frequently. We're definitely benchmarking kind of like open source models versus Haiku. This is also why it's really important to have kind of like a model neutral harness. It's not just that you'll want to switch the main driver from Opus to GPT. It's that you'll want this system to be an amalgamation of different models for different needs at different points in times. And so generally we see kind of like a pretty smart main driver with some sub-agents that are smaller and faster and cheaper in quality. And so, yeah, I think being able to mix and match models at different points in your agent is really important.
When we do this, we take a very scientific eval-driven approach, essentially. So so most of the stuff we end up building is not a coding agent, actually. It's a use case agent. There's a workflow that exists inside of a company. They think that workflow can be automated in some way that couldn't with traditional software. You build the evals for that, and then you prove essentially that there is like efficacy in the LLM. So you take the most expensive, smartest model that exists, and you just say, cool, we prove that this can be done. And now we have a benchmark. And then we start to look for the intersection of like cost and reliability that is acceptable on that agent. And of course, agents can have many models. So you're looking inside of each component on tuning that, but you need those like unit level evals to do that. And then you need the kind of integration smoke level eval to make sure the whole thing did, each unit worked, but the whole thing doesn't, kind of thing. But you can kind of start ratcheting down. And we're seeing a lot more interest in open source models, and a lot more interest in, or just turning the model down from like an Opus or a GPT-5.5 to something faster. Even if it's not cost, the latency starts to become an issue, especially in these like kind of active agents where you're talking to them.
This is why Austin and Focused are the best. Like, that is such a good answer, and that's exactly the right thing to do. And so, yeah, I mean, if you guys haven't already, if you want that to be done at your company, talk to Austin and Focus.
Thank you.
I'm curious, are you seeing people like fine-tuning models?
We're starting to see more conversations around it, yes, but not in production yet. A lot of these enterprises have really sophisticated data teams, and so they're treating older, more traditional like regression models as an integration point for like a tool call, but they're not fine-tuning open source like Gemma or something like that yet. They're talking about it.
Yeah, we're mostly seeing that in some of the more like AI natives that are running at really high scale, because I think when you have that, you A, have data, you B, have a lot of costs you need to manage, and C, you've found a workflow that's clearly valuable and people are willing to pay for that. And so we're starting to see more of that in the AI natives. We're thinking a bunch about that and like how you can use traces in LangSmith to do that. So if anyone here is interested in exploring that, would love to chat about that.
I mean, the fine tuning stuff is going to come. And before I started Focused, I ran engineering for a division of Braintree, and we had an incredibly sophisticated data team doing risk management. And so as those people move out of Hadoop and into how do they fine tune an LLM, like that's going to come. And those people are there, the knowledge is there, and the data is there. And so it's just going to get pulled in, I think. I think one thing I didn't touch on that does come up in a lot of sales calls is authentication and authorization. Like, that is a really tough question. You have an ambient agent, you have a human kicked off agent. What patterns are you seeing come out of the AI native space? What are your enterprise customers doing when it comes to like, how do you authenticate an agent and get that all the way through tools and back out again?
Yeah, there's generally two patterns that we've seen, and we've built these both into Fleet, which is our no code offering. It's easier to do it in Fleet than in the open source, because open source is so open, you can do whatever you want. In Fleet, we have more control, and so that's where we put a lot of our best practices. But there's two patterns. One is called kind of like on behalf of. So when a user is interacting with an agent, the agent will basically act on behalf of the user. So if it's interacting with Slack, it will use usually we use MCP, and MCP uses OAuth2 as their credentialization broker. So it will use OAuth2 or use my OAuth token to connect to Slack. It will only see what I can see and then pass it back. The other model we see is we call them clause, but it's basically just like a fixed identity for the agent. And I do think OpenClaw started to popularize this more, because you start to think of the agent as its own person. I know multiple companies talked about making it easy for OpenClaw accounts to set up their own accounts, because if I want to give OpenClaw access to Box for whatever reason, I might not necessarily want to give it my Box account, but I want it to have a Box account, and so you can create a seat there almost for the agent. I do think there are like interesting middle grounds that are not super solved by either of these. So you might want an agent that has my credentials but only a subset of them, and that like fine grain access is not super well supported by a lot of providers these days. So one of the things we do in Fleet is, sure, you can give it access to the Notion MCP server, but you can maybe remove the like write tool, so it only has read. That doesn't perfectly solve it, because I might want to say, hey, only give it access to these pages in Notion, and that's not solved. So it's not a perfect solution. And then the other thing you can do is you also just have kind of like authentication around all of these agents. So if you have a clause style agent that has access to a fixed set of credentials, you might not want everyone in the company to have access to that. And so we've built that into Fleet in terms of having just like a control over who can access it, who can run it, who can edit it.
there is like a security model that you kind of have to hammer into your security teams, which is like sometimes agents act as a user inside of systems and they get provisioned user credentials. And then you just need really, really good tracing, auditability, observability of what's happening. And you need all the agent observability that like we love out of Langsmith. And then you need traditional observability as well to look over like the tool call that called the other system, that called 6 other systems, pulled data from a database, and then like worked its way back out.
We built Langsmith observability initially to help with just like making the agents more accurate and hallucinate less. But it's a fantastic like audit log for everything that happens. And we see a number of people using it that way.
It is a primary like conversation point when we go into enterprises and they're like, how do we know what they're doing? Like a Langsmith demo is like, this is your governance tool. It is your audit log. This is your data retention. If a compliance officer or regulator comes and says, why did this agent do this? Like, the high cardinality querying of the agent stuff like lets you essentially pull exactly what happened and be like, this is what happened and why.
There's a great story I love to tell of a data scientist at one of the big banks in New York. And they have to go through a model risk management process when they're trying to publish anything in AI. And it's scheduled for 30 minutes, but it usually always goes over. And she just rolled up, showed them Langsmith for the tracing of everything that happened, showed them evals as well, so she could say like, hey, these are the scenarios that we tested. This is how it does, and she finished it in record time.
Amazing. This is like, it's so funny. Like these things just happen. Trends come around. Life repeats itself. At HCSC in a past life, I remember sitting in a room with their security officer, head of software engineering, and a few other people. And we were trying to explain how like filling out a 100-question Excel document for every change was like super redundant because they now had like Jenkins set up, they had Git, they had all these other things. And with CI and Git, you had every question there and you couldn't lie. Like, because in the Excel document, people kind of like, well, that one, yeah, we didn't touch that. Like, so it was like this, and this is just happening again. And I think Langsmith is a really great place. Like the visualization it gives people is incredible. I think like the last question I want to talk about, because I'm actually like, I struggle with this and it's why I love LangChain. So we bet focused on LangChain hard. And the reason we did that is because it's the same reason like I love like any framework. Like I like abstracting what I think is like trivial or eventually going to be something that I'll want to swap. And so where do you see differentiation coming in like the frontier model space over time? Is it going to be the harness? Is it like LangChain is going to commoditize all of them and it's just like everybody should have started there, but they'll eventually be there kind of thing?
Like how will we differentiate?
Yeah. Yeah. And what matters for these frontier labs? Like why are they pushing their agent SDKs so hard? That kind of stuff.
So one, I think like the obvious counter positioning differentiation that we have is like model agnostic. And I think that's, I think there's some lip service about supporting kind of like other models, but in practice, they often rely on APIs that are only available to that provider, and they're obviously not incentivized to support other models. And so model agnostic is a big part of our differentiation. We think that's super important. There's a blog from Neil, who's one of our deployed engineering leaders. He used to work at HashiCorp, and he saw kind of like the whole cloud transformation era, and cloud agnostic was really important there. And it was mostly used as a defensive mechanism to against lock-in and kind of like rate increases. And that's absolutely true of models today as well. You want to use model agnosticism as a defensive measure, but you also want to use it as an offensive measure. A new model comes out, you need to be able to switch. Like that didn't really exist in clouds. It's not like there was clouds leapfrogging each other for kind of like capabilities every 3 weeks. But that happens now. And so model agnosticism is a huge part of that. As for and by the way, this also ties into why the model provider, or actually, yeah, kind of related, like why are the model providers doing a bunch of stuff in the harness space? I think they know that the base LLMs themselves are pretty easily swappable and commoditized, and there's not a lot of lock-in. It's pretty easy to switch between different providers at this point. There's some mild, there's mild prompt tuning things you need to do. You maybe need to switch a parameter or two, but it's pretty easy. I think it becomes a lot harder when the provider is viewed as kind of like a stateful service, whether that's because it actually is stateful and storing long-term memory there, or because it uses a harness and that harness relies on like a compaction API, which is stateful, and that makes it harder to switch. So I think there's different levels of lock-in. I think like if you're just using like the raw completions API, very easy to switch. If you're using like a harness that maybe calls out to like uses properties of the API that are specific to OpenAI or Anthropic, harder to switch. But the worst is when, and I think this is the direction that everything is going, is when these systems start to become stateful, because then you're building a lot of this long-term memory, a lot of this state that is learnings of your product, of your company, of your org into these, and kind of like having lock-in there. And I think that gets to maybe like the third thing I'd say, which is like when we started Deep Agents, which is our agent harness, it was unique to be an agent harness. There wasn't a lot of agent harnesses. There was coding agents, but Deep Agents is more general purpose. And so we took a lot of learnings exactly as you said, or from Manus, Claude Code, and built that into kind of like a general purpose agent harness. I think nowadays, honestly, it's not unique enough to be an agent harness. There are other options that are similar out there or starting to get similar. And so we spend a lot of time thinking around like, what is our differentiation? And I think the angle that we're kind of like pushing towards is this like continual learning, memory, kind of like adaptive harness, and adaptive on a few dimensions. We want the harness to be really good, and we think this is, by the way, we think this is exactly, well, actually, I'll talk about what we want the harness to do. So we think there's three areas to kind of like continual learning in the agent space. There's the model, there's the harness, and then there's like the memory, the context that sits outside. So like the memory or context that sits outside, we're spending a lot of time thinking about what does memory look like. We think it looks like a file system in a lot of cases for procedural memory. And so we're building into Deep Agents really good ways to mount these kind of like virtual file systems, which serve as memory there. Engine, which I mentioned previously, we also view as a form of memory. It runs in the background. It looks at traces and then updates things. It can update that memory. At the harness level, you want to be able to tweak the harness in a bunch of different ways. And so the harness is open source, Claude Code isn't. And so that's a big differentiation right there. And then model. So part of the reason I asked about post-training is like we do want, when you post-train a model, you'll probably want to post, if you're training on it for an agent, you need to post-train against a harness. And so I don't know exactly what this looks like, but we want to make Deep Agents the harness that's like easiest or best to post-train against. And we think that these are all going to be pretty differentiated from the model labs because A, they're not going to want you training on open source models or porting that model elsewhere. And then memory, that they absolutely want to do memory, but I think I think you'd be pretty foolish to do memory with them. And so we think that's a differentiator as well.
Yeah, and then there's like also just if your entire agent stack is built on the OpenAI or Anthropic Agents SDK, then that all has to come out too, right? Like it's even just the code itself ends up being the lock-in, where a LangChain allows you to swap even that like just the raw lines of code. I'm really glad you talked about Deep Agents a little bit because my marketing team and yours told me we needed to talk about Deep Agents. There is a constant debate at Focused. We're way over. My little clock is red by 10, so I think we're going to give the room questions, but there is a constant debate at Focused, and I want like your hot take, 5-sentence answer on whether or not you should build a Deep Agent or a LangGraph workflow and how and why you would make that decision. Because we have a lot of advocates for workflow, LangGraph, deterministic style versus Deep Agents, and we have the opposite.
At this point, whenever I start building something, I start with Deep Agents. I think it's more flexible and it's easy to get started. I think if you go down that path, if you keep on building and you find that you need really, really high determinism and correspondingly probably like accuracy, LangGraph is still the right way to go for that. And so we see a ton of LangGraph usage still and in kind of like financial institutions and other regulated bodies, and they hate Deep Agents. But every startup we talk to loves Deep Agents.
Maybe it's a reflection of our customers. The other thing I will say differentiates LangChain for us, and I like all the stuff you're saying about like making Deep Agents more competitive in like the post-training space and all that. It's honestly you have competitors everywhere. at like the harness level, at the observability level, but there is no competitor that I can think of or name, and I've tried to find them, that competes at every level. And so when an enterprise or one of our customers is looking to answer, like, how do we do AI at my company? And you say, look, we give you a model agnostic, foundational lab agnostic, or frontier lab agnostic framework. We give you agent graph tools, deep agents, observability, testing, so evals, and the compliance that surrounds all of that. Like, and you don't have to yak shave about which tool and configure it all together. Like, that is a massive differentiator to us. And it's a really nice way to talk about LangChain inside of an enterprise.
100%. And yeah, I mean, I'm sure a lot of people here probably have like AI vendor fatigue. I've got told this many times because there's so many people building all these picks and shovels and tools. And yeah, my pitch would be just come talk to us. You don't need to talk to anyone else.
And then we'll help you build it. Let's do some questions. You were up first, so, and then you get to pick the next one.
All right, cool. So I have two questions, one for my business partner and then one for me. So my business partner wanted to know, how did you go about finding customers and then monetizing that? That's my first question. And the second one, just for me, which is a little bit quicker. You guys were talking about evals, which is for the longer term like performance, but in real time, how are you seeing your team and your customers use world models to improve like runtime and performance?
Use world models?
Yeah.
I don't think I don't know if we're seeing anyone do that. What are you seeing people do, or what? How would we do that?
Well, that's a way to simulate, rather than just waiting on the next token to come out. You're actually kind of, and then kind of seeing at the end how it's running. You're comparing it to a world model. Now, there's a lot of thought going into it. Which model do you use? How do you develop that model? But there's been some papers about that in the last 6 months.
I need to go read those papers. I'm excited to read those. I don't think we're seeing people kind of like do that at this moment. I think for the production, unless I'm misunderstanding, but like I think we're seeing a lot of use of the frontier models and kind of like these agentic loops. I'm assuming by world models you mean like the stuff that like Fei Li is working on and that type of stuff.
Yeah, I know. I saw you at the Daytona Compute Conference. So yeah, she's one of the people, and there are a few other people. I think I'll try to get those papers and send them to you.
Yeah, I'll admit that's an area of research that I haven't paid a ton of attention to. And then for the first one, I mean, LangChain started as open source. And I think one of the things we realized early on, kind of to your last point, is like, there's so much, it's a greenfield space. There's so much to do. And so the way that we went about kind of like thinking about just like getting customers was, well, for the open source, the way we got customers was just tweeting about it. Like, it was a side project, built it, tweeted about it, added some more stuff, tweeted about it again, kept on doing that. For the commercial stuff, we realized pretty quickly that the big issue with building agents was just the reliability of them, the getting them to be accurate enough, not hallucinate enough. And so the first thing we built commercially was this observability and evals platform. And my background's also in like ML ops. And so I was building that for traditional machine learning systems. And so combo of like talking to early open source users, but then also like background in ML, figured something like that would be useful for this era.
Hi, Mr. Harrison. I met you at the GTC this March, and I was deeply impressed by your presentation at that time. And you talk about AI native. Do you think LangChain is an AI native company? And the second question is that I'm a UC Calgary student. We are building the multi-agent system for scientific discovery. And but when we like build this system, when a new issue appears, like we will consider maybe assign a sub-agent to solve it. Do you think it's a good solution?
Yeah, so first question was around kind of like AI native and what I consider LangChain AI native. And then the second question was around multi-agent system and using sub-agents to solve new issues as they appear. I think maybe I'll answer the second one first. I think multi-agent systems are definitely like interesting because I do think, I have like some mixed thoughts about them maybe. So like, I think you can probably get a lot further with a single agent than you might think initially. So like, I think one mistake that I do see people making is splitting things up into sub-agents too early when, each system prompt of the individual sub-agents is maybe only like, I don't know, like 500 tokens or something like that. Just put that in the main agent prompt. And so I do think that is one mistake that we see people making. Having said that, like I absolutely think there are places where like sub-agents are useful. So we have two different types of sub-agents in Engine right now. One is to go and research go investigate particular traces. And then the other is to come up with kind of like fixes for things. I think if you can isolate out a problem, like one of the big benefits of sub-agents is context isolation. You give it its own kind of like thread to do things in. And so, yeah, solving kind of like new issues as they occur seems like something that would benefit from that. And I imagine if the system gets to a certain level of complexity, that's absolutely worth getting split out. As for AI native, yeah, I'd absolutely consider kind of like LangChain AI native. The term also, the framing, someone on our team came up with this, but the framing that we use internally is like AI pilled versus non-AI pilled, and then size. So like I think Uber is a great example of clearly a very AI pilled company, and honestly a lot of their like AI processes may be ahead of where LangChain is. And so I'd say we're both kind of like in this AI pilled. We're just a small AI pilled company, and they're a big AI pilled company.
Sorry, since you talk about traceability, like if I didn't build my multi-agent system using the LangChain framework before, but I heard you talk about Longsmith today, and if I want to use Longsmith without using it for the multi-agent system, do you think it's workable?
Yeah, absolutely. So one of the things that we did early on was we made LangSmith framework agnostic. So you can trace any framework or any just like arbitrary code that doesn't use frameworks. So we can ingest events via OTel. We have our own decorators in Python and TypeScript and Java as well. And so yeah, LangSmith works with all AI frameworks and including just like normal code.
Hi, my name is Gautam. I'm with Reply. I think we're one of the we have partnership with LangChain in Reply. So I think you were mentioning about the fine tuning. One of the few resources I found it very helpful is LangChain Academy. Whenever I want to learn about something, LangChain essentials and short courses. That is any courses or like any content that you guys coming up for the fine tuning and the more of the evals content that we can build in the end-to-end workflows and all this stuff.
We don't have any plans for a fine-tuning course, partially because we think it's still really early and we want to work with a number of customers to do it before we teach about it, because we want to learn like what the best processes are, how we can make it easier. But after we do that, we'll absolutely put up course on LangSmith Academy for it. And one of the courses that we do have coming out is about deep agents. So we had for a while like a course on building your own deep agent on top of LangGraph, but the new course that's coming out in a few weeks will be using deep agents, our library, to build more complex agents. So if people haven't checked out LangChain Academy, we have a really good education team, and I'd encourage people to.
Hey, we talked about Poly, we talked about Insights and Engine. I want to hear about what you learned about evals and how you're using them in all three and how they changed or evolved along the way.
The biggest learning is definitely, and the biggest evolution is definitely these like Harbor style evals for like stateful services and long running agents. So Poly is a chatbot. I think we wrote that one in TypeScript. So I think we just use our Vitest integration to kind of like test some of the chat things there. Insights is actually a LangGraph thing under the hood. And so I think we there have more kind of like unit test style evals for different parts of the LangGraph flow. But Engine it's the most agentic. It's the most stateful. It decides when to write to different services. And so the big learning there was like we need to use something like Harbor to run these longer running stateful services in. We need to create these like mock services. And so that's, we'll be doing actually a bunch more content on how to use Harbor for these types of evals because we learned that doing it with Engine.
So yeah, just kind of off of that question, like with a lot of use cases in healthcare, like would there be, does LangChain kind of like support encrypted results, like using like, I don't know, like encryption, like homomorphic encryption or something like that?
Yeah.
Working with encrypted data and like making decisions off of that.
So there's a few parts of the LangSmith platform, and I'd have to check for each of them, but I know for LangSmith deployments, which is our deployment offering, we do support bring your own encryption in the persistence layer that we ship. So LangSmith deployments comes with short-term and long-term memory, and you absolutely probably want to have that encrypted if you're doing anything with kind of like sensitive data. And so we support bring your own encryption for that. For the LangSmith tracing, I don't know if we do directly. We have a number of customers in more regulated industries that deploy us within VPC, and so that's usually how that's dealt with.
So we deal with a couple LangSmith customers. There's three ways to run LangSmith. One is SaaS. Two is SaaS but self-hosted data with like encrypted data inside of your own cloud, and then the third is like hosted 100% inside of your own cloud. And so depending on where you're at, if you're like need to be HIPAA compliant, all that kind of stuff, you can pull it all into your cloud, and the architecture only has one phone home, which is just a license check. So it can keep it all kind of inside of an encrypted space that's watched by you.
I'm building a learning and memory system, and I'm trying to test it with A2A, like agent to agent and human to agent interactions. And what you said about a simulated environment really struck home because I'm having to build a terrarium. I call it, my branch is terrarium. Do you have any tips for someone who's building their first one of how to set that up, how to think about architecting it to help test that system?
The only real thing we've learned is that it's helpful to have like the list of scenarios that you want to test ahead of time and then build the environment around those, rather than kind of like building an environment and then being like, oh, let's test this case. Like if you know those ahead of time, this is why also you do probably want to build simulated environments for complex things if you want to have a really robust way to test them, is because you want to make sure they're built in there. It is a really hard process. One of the big things we're thinking about is, can you take traces from the agent running and somehow turn those into one of these synthetic environments? That's like an open research problem. We're talking with a few of the Neo labs about that, but I tried doing it and it was really hard. So there's no...
Figure it out. Can you do LangChain and then we can...
Yeah. LangChain, I like that.
Yeah, that's good.
Hey, so it seems like a lot of the eval talk that you're speaking about is really focused on the concept of accuracy, which, at least from the work I've done, does not seem to be necessarily the way in which, especially when we're talking about these deep agent type of systems that are doing like multiple amounts of capabilities across a fairly complex environment, doesn't seem to necessarily be the way to go. And I'm wondering about, what is LangChain's tooling when it comes to looking at more, let's say, precision-based approaches that are looking at look at instrumentation or observability of the models, like actions over time, to see broadly, are these going in, let's say, using the good tools for, let's say, the goal as the goal that's looking to be achieved, because broadly in these accuracy-based evals, if you're doing something that's enterprise type of work, at 95% to 5% of the time, you have a very unobservable type of failure, then that's fairly negative for your use case, I would say, right?
I think there's a few ways that we see people kind of like tackling this. So one, like I'd call out for the longer running agents in particular, what correctness or what accuracy means isn't necessarily like comparing an exact answer to another exact answer. It's oftentimes running a series of assertions against anything from like the LLM output to artifacts that are created to the trajectory itself. So for example, like terminal bench, the way they score terminal bench is by running unit tests. And if it passes the unit test, it passed. If it doesn't, then it doesn't. And so like, obviously that's an easier one to do, but you could have that style of kind of like assertions against, again, either like the LLM output, any artifacts or files created, or the trajectory itself. I think there's an interesting question of like, how much do you care about the trajectory versus kind of like the side effects that it did. So for example, if you're running, let's move away from coding, but let's move to maybe like a data analysis workflow. If you want the agent to create a new table, if you have this properly sandboxed environment, you can basically compare the state of the database before the agent and after the agent to what you expect it to be after the agent. Is the table the same? Does it have these columns? Does it have these things? Does it have any indices? And I think there's an interesting question of like, do you care if the agent took 40 tool calls to get there, or if it took kind of like 3? And you might care for different reasons. One is obviously cost and latency, and that can be measured. But the other is like, as you mentioned, in some enterprise situations, you kind of want to know that it's doing things in a certain order and it's not doing wrong things. And so I don't think you necessarily have to test that trajectory, but you can if you want to. And I think like one of the big things that we're doing or trying to do in LangChain is basically standardize on what this trajectory looks like and make it really easy to get this trajectory, which is basically a list of messages out from the trace, so that you can test against it or assert against it or use it in an eval or something like that. So I think like accuracy is more complex than kind of like in just like the single LLM call world. And then, yeah, if you want to test trajectory, you absolutely can.
Hi, thanks guys. I have a question for, I think, the United folks as well as y'all. Something I've heard y'all say is like basically a repo or directory with a bunch of stuff in it seems to be pretty effective for, holding agent memory. And I was just wondering, like, that sounds like an S3 bucket with a bunch of stuff in it to me, and like, is that basically what y'all are saying? And if so, what structures would you recommend for like laying that, S3 bucket out, or, whatever directory out? And are there any interesting data types that you guys are interested in? Like, is it just markdown files and Python scripts, or like anything to share?
I'll give a quick answer, and then I'm curious what you guys have to say. But I think the important thing is that it's exposed to the LLM as a file system, and the reason for that is LLMs are really good at working with file systems. They can ls, and they can grep, and they can glob, and they can write, and they can edit. But under the hood, you could store it in a real file system. You could store it in S3. You could store it in a database. And then for the file types, I don't think it matters. The only thing I'd say is sometimes in deep agents we have this concept of a virtual file system where it's not a real file system. It's just it's a database, and then it's exposed to the LLM as a file system. If you have Python scripts in there, you can't run those unless those are actually materialized into a real sandbox on a real file system that has a real running Python process. So if you're using a virtual file system, then you just can't run code scripts. So we mostly see people doing markdown or things like that. If you are running a real file system, then yeah, you can do whatever you want. But I think the important thing that we think with deep agents is it's just exposed as a file system to the LLM. To the human, it could be exposed whatever format you want. That's that's less important here. But yeah,
I really wouldn't add anything to that. So
It is that simple, in some way. Harrison, LangChain team.
I guess one short thing I would add to is definitely, I mean, you did such a great job covering it, but organizing the file system in a way that you as a human would like to have just neat code. And so we have tools that, the problem with with Claude, when you added, this used to be a problem, when you added too many MCP servers, it would get confused and it would pick the wrong tool for the wrong job. But then their approach was essentially a tool to search for tools. And in that similar fashion, if you have a file system that's very organized around how you want to navigate through it, I think that makes the problem a lot less challenging for the agent.
skills.
yeah.
I learned tonight that it's Harrison's first time in Chicago. And so
I love
everybody,
It's great.
thank you. Thank you, Chicago Tech, for showing up. Thank you for asking
guys for
awesome
coming.
questions. Thank you for participating. I hope we showed you what the second city is all about. And thank you all for coming a ton. And we'll see you at the next one.
And thank you to Austin and Focus for hosting.